Yeah. Oh, do you want a ginger snap? Yes. As long as you're, yeah, you can cross. That's fine. Just don't trip over my wire. You want a ginger snap? Huh? You gotta come and get it. If you want it, you gotta come over here. No, I guess not. So, I have borrowed some donkeys who are ginger snap loving donkeys to talk about prospectors, and I've put on my best prospector suit too. So, the normal picture of prospecting is you have your miner with his gold pan. Yes, I know you want another ginger snap, and now you just knocked it out of my... You have a miner with a burro and a shovel and a pick and a sack of beans and a gold pan. The burros, no, the miners, the prospectors like beans. So the burro part might be okay, but the rest of it is total fiction. Because what the actual prospectors who really found things like the molybdenum and the zinc and the nickel and the iron and the lithium and the tungsten, you're just bound and determined you're going to get my finger, aren't you? They had other tools. For instance, they had, you're not going to eat this. This is not going to be eaten. No. They had one of these. For all surveying purposes, they would have a Brunton pocket transit, which we've talked about in other videos. And you use that for mapping your ore bodies and lining up your claims and just generally trying to find out where you were. That is not edible. Sorry. Oh, this is great. Yeah, we might have to get you in some videos again. You're doing such a wonderful job. So, yes, I know you want another one. Here, there's one around too. Are you jealous? Will you come over and get a video? Will you come over and get in the video? Will you come over? No? Okay. Well, we know somebody who will. So they needed that for locating things. And they needed some reference works, which were usually little pocket books like this that contained various works we'll talk about a little later. Yeah, I know there's one more, isn't there? And they'd usually have a slide rule so they could, calculate things. And then they needed a pocket chem lab. And the pocket chem lab consisted of, well, I have some litmus paper here, which they occasionally used, and a charcoal block, which I've attached to a wire. That's very useful. We'll discuss that in a minute. And for a source of heat, you probably had a candle like that. And maybe a lighter, some sort of lighter. And then the final piece was this. This is a blowpipe. And by blowing, yes, you're doing a great job. I hope that's in the frame. By blowing with this blowpipe, you could achieve high enough temperatures to smelt metals, smelt ores, and also do the most important of the things, which was check the flame colors. Now, back in the 18th century, they noticed that the different elements produced different flame colors. You want more cookies, I know. I don't know if I don't have any more cookies. Sorry. I'd like to, but oh, did we? Yeah, we'll take a couple more. All right. Oh, we got more cookies. Look at that. We broke them up. There you go. Very good. And the question, of course, that you would ask, that we're going to work on here in a minute, is what were the flame colors all about? And the answer to that is the rest of this video. Here is a rough list of the colors associated with various elements, adapted from Chapman's Blowpipe, Practice, and Mineral Tables of 1877, available on archive.org. It was difficult to get good views of the flame colors with the blowpipe, so I used a modern torch in these examples. Here is the violet tinge of potassium chloride. Here is the green flame of copper sulfate. And here is the bright yellow of sodium chloride. In the 18th century, the question was, why do different elements give different colors? The answer was, I don't know. In the 19th century came the spectroscope, the premier tool for identifying elements. Parallel rays from something glowing pass through a narrow slit and then through a prism or diffraction grating to separate colors. The result are bright lines unique to each element. Here is a spectroscope with hydrogen lamp, collimating lens, slit, prism, and telescope. Hydrogen is the simplest element and the simplest spectrum. Here are some more examples of spectra. Note the dark lines in the solar spectrum. This is because light is absorbed by elements in the sun's atmosphere. The dark lines are named after the great optician and physicist Joseph Fraunhofer, who gave them the first rigorous study. The hot element's light line is the same wavelength as the cool element's dark line. So the 19th century scientist answered the 18th century flame color question by saying that each element emits light in unique narrow bands of color. In the 19th century, the next question was, why the unique narrow bands? The answer was, I don't know. 20th century answered the question by finding the electron, a particle of measurable mass and measurable wavelength. The electron can only orbit the nucleus where there is no fraction of a wavelength. Only whole numbers need apply. Therefore, the orbits are in discrete steps around the atomic nucleus. The atom gives off and absorbs light when the electron changes orbit and thus loses or gains energy. Because of the wave restriction, the electron jumps are in discrete steps or shells. In the 20th century, it was then asked how a particle can have a wavelength. The answer was, I don't know. It is still, I don't know. Watch out. You're being pushy again. So that's all I have to say about this, and I thank you for watching.